Alright, so I'm starting with 11 here. What rules are involved here? Chain and product, right? So this is a function of x, this is another function of x, they're being multiplied together, so I gotta use chain. I gotta use product, and then when I go to do the derivative of this part, I gotta use chain. So your derivative here would be the second thing times the derivative of the first thing. What's the derivative of e? E, and then the chain rule part, right? So that'd be like 16x to the third. So that's my 2 and my d1. Plus, then the first thing times the derivative of the second thing, which is nice because it's not a chain rule. That's just 12x squared. So the other thing I'm really trying to show you here, there's a couple things I could, I don't know. You have to have one term, right? So we had talked about taking out like a chunk, because a lot of the other ones we'd have like a big chunk to the 4th power and a big chunk to the 5th power, and we'd take 4 of them and put them out in front. You know what I'm talking about? So if you have e's, you get the same chunk scenario type thing. So I'm just trying to like point that out to you. So I can take e to the 4x to the 4th out in front of both of those, and then I would get, I'm going to clean this up on the inside in a second, but it would look like that. That's probably like the main point of my lesson today. Like that's like the newest thing I have to show you. Not that the problems are easy, I'm not saying that, but if you have an e, that's just like a chunk, like you can pull the whole thing out, and then I could clean up the inside too. So this would be like 64x to the 6th plus 80x to the 3rd, and then 12x squared. So you wouldn't be responsible to do this, but you should be able to kind of understand what they did if they made this 16x to the 4th plus 20x plus 3 with a 4x squared out there. You'd have to take out the e. That's like the main chunk that you'd have to take out. I wouldn't hold you responsible to take out the 4x squared. But again, like we talked about on multiple choice, they'd probably do that. So can you guys identify that these are the same thing? And that's the whole, you don't have to do it, you gotta be able to recognize it. Fair enough there? So the only point I'm trying to make there is if you have e to a power in 2 different parts, pull it out in front, just like you would with the chunk. I'd like to do another one or two, but you guys tell me, like, look through it and see, like, holy crap, this one looks tough, or whatever you got. Whatever you see. Maybe let's do this. Try 20. 20 is interesting. Yeah, ln of ln. In. 3x cubed. I'll give you a minute to try it, then I'll go through. Mitchell, you okay? Okay. Livingston, you okay? Okay. Monroe, you okay? Okay. Morlock, you good? Austin, you good? Okay. Caitlin, how you doing? Okay. Just checking in. What's the big guy? Like the very outside outline, right? Then your middle guy be the second ln. The little guy's 3x cubed. Okay, so this is like, you might want to write it like ln, parentheses ln. 3x cubed. I don't know if that'll help you see it or not. But so this is your big, your middle, and your little. So the derivative of ln is 1 over. And then I move on to the next thing. Well, the derivative of ln is 1 over. And then I move on to the next thing, and that'd be 9x squared. So I'm going to clean that up. I'm going to simplify it, but that would be your first step. 1 over the thing that's being ln times the derivative of that, which is 1 over the thing that's being ln. So you got like this just chain reaction thing. So you would end up with 3 over x times ln of 3x cubed. Because the 9 divided by 3 would give you 3. The x squared over x cubed would give you this x. And then this would still be there. So this would be your answer. How many had that? Oh, I'm sorry. Couldn't see that. How many had that? Questions on it? Like, where did it come from? Where'd you get it? Why'd you get this? Like, does it make sense now that I went through it? Okay. Pick out another one. Or two, or whatever, that you just look through there and you're like, you know, if this one looks hard, what? 23. Okay. So the first thing I would do there would be rewrite it. So this is to the 1/2 power. Is the sign being raised to the 1/2 power here also? It is not. So sign is your big guy then, right? 1/2 is the middle, and then the inside stuff's the little. So what's the derivative of sine? Cosine. How many of you were ready for a quiz today? If I'd given one, you'd been all right. Cosine, and then you leave the little guy alone. Oh, is that what you were asking me more like? If there was a quiz? I didn't hear you. I'm messing with you. Times, bring down the 1/2. Leave the little guy alone. And then times the derivative of the inside. When's that first step? Okay. Then I'm going to start like moving things. So 1/2 times negative 10x. I'm just going to make that negative 5x. I'm going to put the 10x to the 4th. Thank you. So I'm going to put the 5x to the 4th up there. Thank you. Cosine of negative 2x to the 5th plus 1/2 goes on top, and then the negative 2x to the 5th plus 1 goes on the bottom, and the exponent becomes positive. Can I cancel those negative 2x plus 5th? Can I cancel the parentheses? I cannot, because one's being cosed and one's not. Quinn, is that good? You weren't even saying you know how to do it. You were just saying, like, go through one. Yeah. Any other ones that you're looking through and you're like, this looks hard, go through this? What number? 18? All right. So we got a choice here. We could do quotient rule, which I don't think is too bad because you don't have any negative exponents or anything. Or we could bring it up and make this like all to the negative first and do product rule. But then we're going to get like a common denominator type issue, and I think it's probably best to avoid that if we can. So I'm going to do quotient. So quotient, remember, is the bottom times the derivative of the top. So what's the derivative of e to the x to the 4th? E to the x to the 4th times 4x cubed. So it's the bottom times the derivative of the top. Remember? Wow, that's way zoomed in. You can see that really clearly, though. Minus the top times the derivative of the bottom. Well, what's the derivative of the bottom? E to the 2x cubed times 6x squared. Oh, jeez. That was just a vision issue. Okay. So then 12x to the 4th. Thank you. 10. I'm just looking for the worksheet. Okay. Bottom times the derivative of the top. So e to the x to the fourth, 4x to the third. Minus the top times the derivative of the bottom. So the derivative of the bottom is what? 4s. E to the 2x to the 5 times 10x to the fourth, right? Alright. I keep zooming in on that because I think it's going to help me see on the paper. Which makes 0 sense, but I continue to do it. All over the bottom squared. So we get that. Can I cancel out an e to the 2x to the 5th plus 2? I cannot, because I have 3 terms. I've got one here, and one there, and I don't have that e to the 2x to the 5th plus 2 in this term. So it's got to be in every single term if you're going to cancel. So I'm just going to leave that on the bottom as a squared. So we're just going to work with the top. And then this is pulling out those chunks again. So I have e to the x to the 4th is a common chunk in both of these two terms. So I'm going to take that out in front. And then my guess is, like in the answers, they probably took. Let me stop first there. Do you guys see what I did there? Questions on that stuff? So if you take the e to the x to the 4th out, you just kind of write down like the two things that are left next to it. Yeah. So it's not multiple terms; it's all one term. So the negative, it's minus that whole term. You're thinking of like distributive property, but there'd have to be a plus or minus sign in the middle for it to be distributive. So the answers probably went a step further, and you could take out a 2x cubed here. You want parentheses here?
It looks like 2 terms. I guess it's multiplication, so technically it's not.
Yeah, so technically it's not, but if the parentheses help you like see that, then that's cool. There's nothing wrong with them. So again, like they probably took out a 2x cubed here also. You wouldn't have to do that, but you should be able to recognize that, you know, if that's what they did. Does that help? Who asked that? Marla? Any others? Are you looking through and you're like, this one looks like I need some help or whatever? So you have the rest of today, and then a lot of you aren't going to be here tomorrow, right? Like, raise your hand if you're not going to be here tomorrow. Yeah, okay. So you have the rest of the day and tomorrow to work on this and or your con. Remember your con's due Friday. And then Wednesday we'll move on, and there's 6 more of those, 6 more things to memorize, and we'll start working with those. And then that's it, though. These 16. So today and tomorrow you're working on this and or con. If I can help you, let me know. We're getting close-ish to that gateway I was telling you about. My guess is maybe like beginning of next week. Be that deal. Questions? All right, then. Something's weird today. Something seems weird today. It's a curse?
It's really bad. It's how rough day.